dismissal, right? That they want us to try and talk more like the textbook. I'm not there yet. Okay, I try and use my own words, and that's maybe what some of the difficulty was with last night's homework, because I worded the questions a little bit more, a little different from that. Okay, so this question letter A looks complicated. Okay, let's just pretend that was x over 4 equals 5 over 7. What would I do if that was x over 4 equals 5 over 7? Times by 4. It's x plus 3. We're just going to ignore the plus 3. So I'm just going to call it then x plus 3 equals 5 times 4.
Excuse me for the interruption. With the grade 11 college English students going on to teacher in college.
So what I do, remember that dot means multiply. So what I did was the divided by 4 comes across to be times by 4. All right, Aiden, what is 5 times 4, please? 20, good. Okay, so we're going to have x plus 3 is 20 over 7. All right, when I want to solve for x, what do I do next to isolate it? What's the next thing, please? Yeah, go ahead. Move 3 across. So I'm going to call that x equals 20 over 7 minus 3. Now, I cannot subtract those nicely. What do I do? Go ahead. Very good. I'm going to slide this down if you don't mind. Okay, so it's going to be x equals 20 over 7 minus 21 over 7. Now, I'm going fast. I'm going to slow down for a second. Please be brave and ask. It's Friday, I know. Okay, great. What's 20 over 7 minus 21 over 7? Negative 1 over 7. Negative 1 over 7, all right? So x is negative 1 over 7. Now, this is just algebra, okay? I want to put it in there because it's like solving similar triangles, right? It's very similar. Similar, forget it. Similar triangles, so that's that. All right, good? Somewhat good? Okay, so let's do the right-hand side now. It says, prove that these are similar and then solve for x. In order to have two triangles that are similar, what has to happen? What do we need? Say what? Go ahead. No, somebody help her here. What's same angles? So we need to show that the angles are the same. So to be similar, the angles have to be the same. So if you take a look, right, and again, remember we're just talking about like zoomed in versions. That's how similar triangles work. Alvin, you want to add something here? No? No? You did and then you lost. That's okay.
Oh, wait.
Nick, you had a stretch or an answer?
You just find
Good. Good. So awesome. So up here, what we say is, let's say, I got to find these two angles, okay? So I got to make both sets good. So what you said here was that if I start with 180, I'm going to call that theta maybe. I'm going to say theta is going to be 180 minus 90 minus 40. Which should hopefully equal 50 if I did the math right. So I'm feeling great. Okay? Okay, how do I get the beta on the right-hand side? So beta equals 180 minus 50 minus 90, which should be 40, okay? And then you probably say something like, since the angles are all the same, the triangles are similar. I'm going to slow down here because I'm too excited here. I love trig.
That's it?
Well, not yet. We've got to solve for x still. Okay. Now, the reason we had to show is because you need to get the ratios right, and that's what the ratios will stretch out here for this. But you have to show that it's similar for it to work. And again, we'll get into more examples like that with like crazy triangle diagrams and all that stuff. Okay, but you have to prove that they're similar and congruent before you can do extra math here. Sorry. Yeah, go ahead. Yeah, go ahead. Yeah.
Is it x over 7?
Yeah, okay, so we're gonna do, I'm gonna do big over little this time. You can do little over big too. The reason I want to do big over little is why. Why do I want to write it as x over 7?
X on top.
Yeah. If you have the unknown at the top left, it's very easy to solve. You can just multiply by the denominator there and solve it, right? So that's good. So if you take a look at corresponding sides, and this is for the two people that were writing the test yesterday, and you missed that, this hypotenuse there is going to correspond with the hypotenuse on the other side.
So it was like a different number of constants. So it was 6, it would be x over 6.
Right on. So again, it's the idea between the 50 and the 40 is an x, between the 50 and the 40 is a 7. That's what we're saying there for that. Can someone please give me the other equal sign, please? Yeah, go ahead.
Because number 4.
Number 4, how'd you get that?
Because the other triangle, it says we can go like that hypotenuse and one.
Okay. The other thing to remember here, because we're using big over little, and that's why I read it in the applied class, I'll do it for you guys too, right? 10 is on the big triangle. If you were to write that as 4 over 10, your answer would be completely wrong. Okay, right? Because you're comparing, like, 10 on the big side is equivalent to 4 on the little side. I'm going to pause for 1 second. Actually, I'll solve this first, and then we'll hit pause. Okay, so I have x over 7 is 10 over 4. How do I solve for x now? Bailey, go. No, you don't. You have 70 over 4. Which is 35 over 2. I'm going to call it 35 over 2. Okay, now please be brave and ask here. Again, the idea for all these similar triangles is that you need to get the equivalent angles to show they're the same, and then you set up ratios then for that. Yeah, go ahead.
Say if you're doing like little over big, would it just be like 7 over x
Yeah.
4?
The thing is, if you do 7 over x and 4 over 10, the difficulty though is, like, you need an x in the numerator to solve it, right?
Yeah.
Okay, so if, and I'll just quickly take up 5 seconds here. Like, this is messy to solve. You still get the same answer. So you can do 7 equals 4x. See what I mean? Like, you're doing, and that's an extra step in there, 70. You still get the same answer. You'll still get the same answer, right? But it just takes an extra step by putting it in the numerator. It's a little bit easier to work with. Okay, can everyone close their eyes, put their heads on their desk for a second? Raise your hand if you're horribly confused with what's happening here right now. Okay. Raise your hand if you're sort of confused and sort of get it. Raise your hand if you completely get it. Okay. Because everyone can look up. So you're in luck. For all those people that were sort of confused or completely confused, because today's lesson is based on yesterday's, okay? We're progressing this far, that's all we're doing. It's only today is something completely new, okay? So it's just a little, we're inching forward today instead of stepping ahead by a mile. All right, I'm going to pause the video and then that's a joke to tell, and then we'll get on to today's lesson and continue. Actually, I'll take up 4A and B then.